which basically you have a set of these images that are random. As long as they have overlap, you would be able to identify the orientation, do a dense 3D reconstruction, and get basically a set of points that represent the point cloud. And then laser scanner, which basically does it directly. Now we have mobile laser scanners as well, meaning that it's kind of something similar in between that you can basically put, and it basically emits laser signals, light signals, and it reflects off of the surface and directly gets the 3D measurements there. And then you can use something similar to the structure from motion to get the orientation through what we call simultaneous localization and mapping, SLAM. We're not going to be talking about SLAM. We're mostly going to be focusing on terrestrial laser scanner, but SLAM also with drones is quite a hot topic as well. And there's software there that would be able to process it similar to the photogrammetry-based ones. Okay, so we've talked about how, let's say, our whole process of construction monitoring and control is carried out, right? We said, okay, if there is going to be some sort of deviations between the planned and the actual, that deviation needs to be first measured and then compared with the actual. And if there is any deviation, that needs to be identified and improved. And we said, for instance, in this case of the competition pool, that, for instance, there was some mismatches with respect to the dimension. So there's some quality control issues. And with respect to that, we were able to utilize point clouds and laser scanners to be able to extract that information. Once we have that information, we would be able to extract that information and gather what we want in terms of our key performance indicators. In this case, our key performance indicators is basically whether the dimension matches together with the tolerances between the point cloud, which is what has actually been built, and our BIM or whatever digital model that we might have, right? And we also mentioned that this goes hand in hand with our cost influence curve, right? And what that means is that as the construction or the project life cycle increases in terms of its time, our degree of influence that we have on a change is going to decrease and the cost of influence is going to increase. So what that means is whatever type of deviation we're trying to measure here, the earlier we identify it, the better it's going to be. Now, how can we guarantee that we are going to identify these deviations earlier in terms of data collection perspective? How can we guarantee that? Or how can we basically reduce and mitigate the risk of late identification of deviations? Any ideas? So if we want to identify deviations as early as possible in terms of data collection, can we? Regularly, exactly. So the frequency of data collection becomes very important, right? That means that the more frequent we collect the data, the better chance we have of detecting what these problems could be early on or at the time that is going to be taken. For instance, if we do it every 4 weeks and a deviation is occurred at week 1, what is going to happen? We've identified this 3 weeks later, whereas if we were doing it every week or twice every week, we would be able to identify it much better with much more accuracy and much more frequency. So here the frequency becomes very, very important for the timely identification of these deviations. The second part of it is how well we would be able to analyze this data, so the accuracy of the data, and how well we would be able to basically utilize that information to get our KPIs from that, okay? So here, the frequency and the reliability of the data collection and analysis is key for us to be able to do that. So now what happens? We have point clouds, we require it frequently. Let's see what the characteristics of point cloud is. So point cloud is basically a bunch of 3D coordinates of our surrounding areas. If we utilize, let's say, terrestrial laser scanner or something like this, every part of the project, every surface is basically represented by a bunch of points, okay? What do we have to do? We have to analyze these points in a way that we would be able to identify what those surfaces are, and then whatever information we want from this. For dimensional compliance, we need to be able to identify how well the surface and the dimensions of the object is going to comply with our plan. In terms of progress, we need to see whether that particular object is observed and present on site. So with respect to different information that we require, we would require different types of, let's say, processing of this point cloud that we want, okay? But what does that mean? That means that we still need to collect this and we need to analyze this. Now, in terms of the data itself, you have about 1 million points per second that you're collecting. Every, let's say, monitoring time that you're doing is going to be around 1 to 2 billion points. 20 to 40 gigabytes every time. Let's say you're doing 10 different monitoring locations, okay? And if you're doing 10 projects in 10 days, this would be 2 to 4 terabytes in 10 days. See, it accumulates very, very fast, right? So now there's going to be a give, right? How frequently do we want this information, right? Versus how much risk we have or are going to be accepting for if there is some mismatch, that risk is going to be accepted, okay? That's what we're basically sacrificing here. There could be a possibility of a mismatch, there could be a possibility of a discrepancy, but because of this large data, we would have to basically manage that in that sense, okay? And with that being said, point cloud is one of the types of data and construction projects that will be and is actually identified as big data. Now, what this means is that this big data needs to be somehow managed in order for us to be able to get the construction analytics that we want from it, or the information that we want from it, right? And what we still want is to be able to manage this while being able to have frequent data collection, because we do not want to sacrifice that. And that is basically the area that we want to improve. In reality, we might need that, let's say, every day, but in reality, for practical reasons, we might get this information every 10 days, right? We want to be able to see how we can utilize technology and different strategies to be able to still maintain this one every day that we require, or as frequently as possible, without sacrificing in terms of the data management and various different aspects with respect to that, okay? So let's talk about what type of analytics we can do and what is the process of preparing our data in order to basically gather the information that we want from it, which really is our key performance indicators that we want. So we have some data, we need to process that data, analyze that data, prepare that data, and then get whatever information that we want from the other side of it, okay? So some examples of these, we talked about, for instance, how we can utilize field information modeling to be able to get the point cloud, our 4D BIM, and then identify the status of the project with respect to the progress and dimension. We also talked about, for instance, how we would be able to perform, let's say, point cloud processing to be able to get dimensional verification, as well as, in this case, for instance, static displacement monitoring. Or in terms of industrial construction, we talked about how we would be able to utilize point clouds to extract the information regarding the flanges and basically these modules before they are basically shipped to site, because the locations of these flanges becomes very, very important for us. Why? Because this module is going to be built in a factory. It's like almost the size of this room. Then it's going to be shipped to site. When it's going to be shipped to site in, let's say, minus 30 degrees in Canada, we need to know that these locations of these flange, which these pipes are going to be joins, are going to be in the proper location. How can we guarantee that? We need to be able to basically get the point cloud, extract the information that we want from it prior to it going to site, verify that. Once it's verified, then it could go ship to site, and then over there, they would basically be able to be matched, right? So there are some ways that we would be able to extract information that we want from these point clouds of construction elements in order to get information that we want. So what is the process of preparing our data in order to be able to even start with this? So there's some typical steps in big data analytics. One that was basically specified by Microsoft, has 4 real steps. You collect the data, you process the data, scrub the data, and then you analyze it. So in our case, what does that mean? That means that we collect the data. Our collected data is point clouds, right? Using laser scanners, using photogrammetry, whatever method. Then you have to process this. That means that you have to summarize this information as much as possible to what we want. In this case, for instance, I have a bunch of planar surfaces. I need a process of automatically extract planar surfaces from these point clouds. And now my point cloud has been summarized into a set of planar surfaces with some boundaries around. Okay? Then the second part of this is the scrubbing. Here, what I would say, the scrubbing is how much detail we're going to be basically needing in terms of our KPIs with respect to what has been planned. So how do we want to summarize this information? How are, let's say, these elements identified? What it is from our plan and from our information that we want that we need to be able to extracting there. And this scrubbing is basically coming from our plan side and from our BIM side. Then these two needs to be basically joined together through some analysis so that we can finalize those deviations that we want here. Okay, so this is the process of big data analytics for the preparation of the data in order for it to be utilized for construction analytics for us. Now I'll give you examples of how this could be utilized in earned value management in order for us to be able to basically get the information that we want from it with respect to different levels of analytics. So there are really 4 main types of analytics that you can perform. Does anyone know what those are? Never heard of it? So we have 4 major ones. One is descriptive analytics. Okay. The second one is diagnostic analytics. Yeah. The third one is predictive analytics, and the fourth is prescriptive analytics. Descriptive means that we want to describe the data that we have in an understandable fashion. As an example, earned value analysis. If we can actually get all of the data into one simple curve that will provide us whether we are going to be ahead or behind schedule in an overall project duration, that is going to be an example of a descriptive analytics. Let's talk about diagnostic analytics. That means how some, let's say, deviation has happened. This means what type of activity and why that activity was, let's say, behind schedule. A predictive analytic means what kind of prediction can we actually get? What type of method that we can utilize in order to predict the data and the pattern of the data, let's say, based on previously identified data that we have, how can we actually predict what's going to happen in the future? And then the prescriptive analytic, that means what type of prescription can we actually provide to this, let's say, disease that we have, which is, for instance, in this case, it's going to be delay in construction. What type of actions can we actually take and we can prescribe in order for us to meet the deadline? So I'll give an example as we can go with these 4 types of analytics using earned value analysis and point clouds. So we've talked about, for instance, we have every time that we monitor it, once we monitor it, we go through all of those processes of collect, analyze, collect, basically process, scrub, and analyze, right? We go and we get basically to this point. Once we get to this point, we can utilize that information that we extract to be able to develop a descriptive analytic of the status of the project. In this case, earned value analysis for delay. If we talked about this, if the budgeted cost of work performed is less than the budgeted cost of work schedule, what happens? So if our work performed is less than the work scheduled, it's a delay, right? So we would be able to identify this in project level in a very simple description how it's going to be performing. right? What about the why, or where is this particular problem happening? When you go back, and we would be able to actually see the type of activity that there's going to be some delay. This is a type of diagnostic analytics, meaning that we can actually go and find the source behind this, of why this has actually happened. Now, there are other aspects to this as well that would be different levels of analytics that you can get. For instance, exactly why this activity also was delayed. Some of it would be able to be identified through point clouds. Some of it would not. We need additional data, right? But in terms of what we can get from point clouds, at least we can find the diagnostic of what type of activity was actually delayed that caused this overall project delays. Then we can go and look further into it, right? Now, let's say we go and we monitor it again. And based on the information that we have from different stages of monitoring, we can now go and predict what our budgeted cost of work schedule could be going forward. Or the budgeted cost of work performed would be going forward based on the previous data that we've collected. This is a type of predictive analytic. Given previous information to predict what is going to happen in the future. Now, let's say at this point that we've identified that if we have delays based on previous projects as well or similar situations, we have an action plan. I'm going to hire an additional crew member to basically work on the elevator shaft. Now, once we find this action, so that is going to be an input of an action, what is going to happen? We then measure the response of that action. What does that mean? I've taken an action. How well does that action match with what my objective is, which is to meet the project deadline? Okay? In this case, this particular action has had a positive outcome on our project. What does that mean? That means that we can now have an action plan that we have and a response. When you have many of these available, then we can actually prescribe a particular action in case we have similar circumstances that happen, right? Which is a type of prescriptive analytics. Because in this case, once we do it on multiple occasions, using this action, we now have an action that is related to some outcomes, right? So later on, similar situation could happen, and we have many of this data. Then what we can do, and many different actions, then we can decide which one of these actions we're going to be taking in order to satisfy and solve the problem that we've had. So essentially, in theory, if we can do this in many projects, if we can actually utilize point clouds for this in many projects as frequently as possible, and we can have our action plans when we take actions measured as well, we can actually relate all of these together in order for us to create a closed loop of our descriptive analytics, our diagnostic analytics, predictive analytics, and prescriptive analytics as well, so that we can utilize it for the future. This is one example of the benefits and how one simple data, together with some minor, let's say, addition of different types of, let's say, actions that we would take, could actually support our data analytics as a whole. Make sense? Yeah? Okay. So what is the real challenge? Why is this not being used? Why are we not basically taking this? Well, obviously, one is with respect to the amount of data that exists, right? But then what is the real bottleneck here? If we have many data, then we would have to automate that, right? But the bottleneck is exactly in the automation. If we want to do this manually, obviously, we've also talked about it, that all of these elements, every time that you're basically measuring it, how are you going to be able to even extract the information? And you guys did one example of that particular column that we did, right? In a more semi-automated way, how long that took. Imagine you're doing this on different construction sites or on the same construction site multiple times. It's going to take forever. Okay, so it's not practical in terms of its time consuming. That means that with respect to even taking out of the consideration the amount of data that we have, it's just not possible to process that information and analyze that information on time to be able to utilize that information. If we're getting it every day, but our processing is going to take 2 weeks, it's not going to be even useful, right? And that's what's important here. The other side of it is also with respect to the subjectivity, and we talked about the fact that if we have, for instance, the same set of points that's, for instance, on the top right there, rebar, that I gave to 6 different colleagues of mine, and what they provided were basically different selections of these points, and every time that you fit a cylinder to it, it gave a different result, and that is different from what you can get analytically from these results as well. That means that the processing of it also becomes subjected to the person that is analyzing this, and we want to reduce that subjectivity as much as possible. And this is a prime example for automation. So if we can, yes. You mean the sizes of these? Yes, yes. So this has, I think, like a centimeter or less in terms of its diameter. This was like 2 centimeters. So it was like almost you know, I would say maybe from the minimum to the maximum about half an order of magnitude, maybe like 5 times more. So you go maybe 2 to 3 or maybe maximum 5 times, but it was considerable. Why? Because especially when you have missing data, you're going to have problems with that. Because if you have a missing data, then you would have to really model it in a particular way. Now, if you're basically extracting that, and if you don't extract it properly, it's not going to give you the full picture. As an example, this was, for instance, a project that I did, and I'll talk about this as well. One thing that's there's a problem. If you have, let's say, an ellipse, and if you have data on only this side of it, the possibility of you having to fit an ellipse to this would be the actual ellipse. This would likely be the ellipse that you're going to be fitting to this. This is the deviation that you're seeing there. Meaning that if you have outliers and if you have biases in the locations of these, that would create problems. Now, if you can actually reduce this to another point here, this would be something that is going to be, let's say, closer to this. So it's going to be a bit closer. So dependent upon which points you're selecting, you're actually dictating what your model is going to look like. And that by itself, we can actually analytically extract, especially the ones that are geometrically, you know, easy to identify. You can actually analytically extract that. But yes, in this case, it was very significant. I mean, from my side, maybe my example was a bit biased because I wanted to really show that there's a, you know, there's a disparity there. But it doesn't change too much, you know, what it is. At the end of the day, we are looking for millimeter or sub-millimeter deviation, but even from one person to another, you might get, let's say, a 5 millimeter deviation. If we can reduce that as much as possible, remove the subjectivity, that is basically where we're going to aim at. So manual intervention in this case is also subjective and prone to human error. So what do we get? Right now, we have identified that point clouds are frequently required, repetitive task, challenging to process manually, and it's a non-production activity. If you can minimize this, now that doesn't mean that it's not valuable, because if you have a mismatch of some sort, discrepancy, and you can identify it earlier on, that's much better than identifying it later on, both in terms of liability and in terms of meeting the project credentials, right?